Okay, so in section 5.2, we're going to evaluate and graph polynomial functions. Not so much graph as look at the end behavior. We'll put some pieces together at the end of this chapter to just get an idea of what these polynomial functions look like. The first thing we have to decide is it a polynomial function or not? Sometimes mathematics, when we're trying to come up with something generic that fits all forms, it looks pretty complicated. So they're saying the function depends on x, and this could be a 6, this could be a 5, this could be a 4, so that would be the degree. And this number out front is called the coefficient. And if we put the highest degree first, which is what we do when we're writing it in standard form, this would be the leading coefficient. And so if this was an x to the 6th, the next one would be an x to the 5th, and whatever coefficient went with that one less exponent, et cetera, until we get all the way down to x to the 1st. So this would be the coefficient that goes with the x to the 1st. And then finally, really remember, this is an x to the 0, because anything to 0 is 1. And that would be the very last term, and it's a constant in this case. The x to the 0 we don't write because it's just equal to 1. So here are some examples. Linear functions we recognize. Y equals mx plus b in very generic form, or function form, f of x, same thing as y. Since this is an x to the 1st, this is the leading coefficient that goes with the x to the 1st, and that's the constant. F of x equals 5x minus 7, etc. 2x squared plus 1x minus 9. Leading coefficient would be 2, degree would be 2, constant would be negative 9. Degree would be 3, leading coefficient would be 1, and the constant here, there'd be a plus 0, so the constant would be 0. Leading coefficient again would be 1, degree would be 4, constant would be negative 1. Okay, so yeah, that's in your book. You guys will have a copy of your text. So the first thing that you're going to do in practice A is you're going to decide, I'm going to zoom out a little bit. Is this a polynomial function? And if it is, write it in standard form from the greatest degree to the least. 2 to the x. Notice the exponent is a variable, so that immediately disqualifies this as a polynomial. The degrees have to be integers, or the powers have to be integers. So that immediately rules that out. Is this a polynomial? Absolutely. What is the degree? Well, I have to look for the largest power, and that's a 4th. So the degree is 4, and I'm going to then write it in order. This function depends on x, and 4th is my greatest degree. The next would be a plus 3x cubed, then minus x squared. And I'm not going to expect you to write this, but think about that. It'd be a 0x to the 1st plus a 0. So we don't have an x to the 1st term, so its coefficient must be 0, and we don't have a constant term, so the constant must be 0. So the leading coefficient, the coefficient out front is 1/2, and the constant is 0. The degree is 4, the leading coefficient is 1/2, and the constant is 0. They just said to write it in standard form. I sort of went into the next one. State the degree, the type we're going to talk about in a minute. So again, I have to think about this. I want to write this. This would be a negative 3x plus 7. I want to write that in standard form. So the degree is 1. That's a 3x to the 1st. And we do have a type for that. We call that linear. We have linears, quadratics, cubics, quartics. I'm not that tied to those. Like the ones we have names for, sure, use them. The ones we don't, it's just silly. And then my leading coefficient, I'm just going to call it the LC here. The leading coefficient is a -3. And they don't ask me for the constant, I don't think, but I'm going to write it. It's a +7. This one is a little tricky because of this guy right here. You start to lose track of what's going on here. Actually, this is just a number. So really, first of all, this is my highest power. So that number would go first in -4x squared. Then I don't see any, so then I would have an 8x. Now the tricky part is this is really a cubed root of 2x. Because again, that's just a number, the cubed root of 2, and then -6. And if you could estimate this is an exact value, the cubed root of 2, you could actually combine those are like terms. But again, the degree is 2, which we call a quadratic. We're pretty familiar with that. The leading coefficient then, in this case, would be -4. And I'll just follow up with the constant. That would be a -6. So the degree is 2. The leading coefficient is -4. The constant is -6. But beware of these things that can sort of try to trick you. And I'm going to go into direct substitution and synthetic substitution. And then I'll do a second video for sort of the graphing part. So direct substitution we're all pretty familiar with. Here's my function, and they're saying substitute 2 in for the function. So I want to replace x with 2. So I want to see what happens to the g function when the x value is 2. That's how I write that. It doesn't mean g times 2. It means put 2 into the g function. Wherever there is an x, I'm replacing x with 2. So I'm going to have 2 to the 5th. Minus 2 times 2 plus 3 times 2 squared minus 9. 2 to the 5th, 32 minus 4. 2 squared is 4 times 3 is 12 minus 9. I'm doing this all in my head right now. Sometimes it doesn't work too well. 32 minus 4 is 28. Plus 12 is 40 minus 9 is 31. Is that right? I don't know. I was supposed to bring my calculator up here. Looks like I forgot it. Direct substitution again. F of -2. So where I like to put negatives in parentheses. Plus 2 times -2 cubed. Minus, this is a great place to use parentheses because my -2 is being raised to the 4th, and then minus 10. So, oops, I should have written here g of 2. Remember, that's a point now. I can see that when 2 goes in, 31 comes out. I'm pretty sure. -2 cubed is -8 times 2. I'll be a little more deliberate. Minus, and what's -2 to the 4th? Well, 2 times 2, -2 times -2 times -2 times -2. A negative times itself 4 times will be positive. 2 to the 4th is 16 minus 10. So I have -2 minus 16 minus 16 minus 10. That's a -32, a -34, a -44. And so when -2 goes in, -44 comes out. I'm going to find my calculator. I don't know how to pause this thing. Bear with me for a minute. So that is direct substitution. I'm going to get back to how I can check this quickly. So what does synthetic substitution looks like? This is kind of cool, and we're going to see this again later, this concept. So here's this idea that I have a function x to the fourth plus 7x cubed plus x squared minus 2x minus 6. Well, there's my x to the fourth, x to the third, x squared, x to the first. That's really an x to the 0, remember. So I take the coefficients, 1, 7, 1, negative 2, negative 6. And then I put this negative 3 over here. And this first number just comes straight down. Whoa! 1 just comes straight down. And then I do negative 3 times 1 is negative 3. And then you add 7 plus negative 3 is 4. And then I do negative 3 times 4 is negative 12. And then I add negative 11. And then negative 3 times negative 11 is a positive 33. So I add negative 2 plus 33 is 31. And then negative 3 times 31 is negative 93. And then add, and I'd get negative 99. So according to this, h of negative 33 should be negative 99. So how can I check that in my calculator? Let's see how well we can see this. So I'm going to go to y equals, and I'm going to plug this function in, x to the fourth, and then plus 7x cubed plus x squared minus 2x minus 6. And then I can go to my table. And if I go to table set, actually, I can just tell it I want to ask it a certain value. So when I go to table set, I say, I want to ask it what the independent value is. So then I go to second table and I say, well, what happens when x is negative 3? And it tells me it's negative 99. Darn, my mental math is pretty good. Now, let's go back to this, because the other thing I wanted to talk to you about is, since I'm on my calculator here, number 18 on practice A is kind of a yucky function, and they want me to evaluate it for 0, 5, 10, 15, 20. Well, let's go back to the y equals, I'll just use the function I have. So there it is, x to the fourth plus 7x cubed. Now, if I want to evaluate that for 0, 5, 10, 15, 20, I go to my table set here, which is second table set, and I want to start it at 0. You guys can see that. I know there's and then I want to go by, let me get a light. There you go. I want to go by 5s. Remember that delta means change. How often, what's the change you want in the table? I want to go by 5, 0, 5, 10. And then I want to say auto. So then if I want to see my table, I go second table. I'm not looking at a graph. And there's my table of 5, 0, 5, 10, 15, 20, 25. Slick way to get a bunch of values. So why are we even doing any of this by hand? I don't know. Because it's good to know sometimes what goes on in the black box and what happens if your batteries run out. So let's do another synthetic substitution, because obviously direct substitution took a little more mental math for me. I had to remember what 2 to the 5th was. Synthetic substitution can be kind of slick. So people came up with these tricks to help them when they didn't have all this technology available to them. So here's the funky thing about this. Notice I have an x to the fourth and x to the third, but I don't have an x squared and I don't have a constant. So the first thing I'm going to do is fill in all the blanks. That's a 7x to the fourth. That's a 3x cubed. I don't have a squared. I do have an x to the first. And I don't have, and just for measure, I'm going to show you that's a 0x to the 0, right? That's just a 1, which is why we don't write it. And then, so if I'm going to synthetic substitute, I'm going to bring down my coefficients. So you need to hold the place for all these other guys that aren't up here. They do exist, we just don't write them because they're zeros. And I'm going to plug in a 2. So how does this work again? Bring the 7 right down. 2 times 7 is 14. Add, that would be 11. 2 times 11 is 22. Add 22. 2 times 22 is 44. Add 49. 2 times 49 is 98. Add 98. So if I plug 2, f of 2, when I plug 2 into the function, 98 should come out. And I'm not going to take the time to check that, but again, you could go to y equals, you could plug in that function, and then you could go to table setup and tell it you just want to ask it a particular value. There's actually another way to do this. If you go to vars, I'll do it this way, and you go to y vars, and if I say function, if I type that in, I can say, here's my y1, tell me what happens when I plug in 2. Now keep in mind I don't have that function plugged in, but if I go back to my y1, it's telling me that that function has a value of 66. So you can either use table or you can use vars. Did you guys see me do that when I plugged in vars? Sorry. Then you go over to the y variables. That's really what that's standing for. I want a function. You could have them. You could have 7 functions plugged in there. I don't know how many. So in this case, I have a function. What happens to if I plug in -3 into whatever's in my y1? -99. So learn how to use your calculator because it can be helpful, I think, particularly on standardized tests. So I'm going to stop there. That's probably pretty long. And that's how you do identify polynomials, leading coefficients, degrees, direct substitution, synthetic substitution, and how to use some fun functions on your calculator.